Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast, Paul Beers.
Hello, everyone. Welcome back to another episode of the Everything Building Envelope podcast. And our guest today is Michael Bousfield. He's the technical director for Cascadia Windows and Doors. Welcome, Michael.
Thank you, Paul. Happy to be a part of this.
Great. So maybe we could start out. You could tell the listeners a little bit about yourself and then about Cascadia Windows and Doors.
Sure. Thank you. Yeah, I'm the technical director of Cascadia, and basically that means I get to split my time between speaking to the industry about our technology and also helping with product development and engineering in our own operations. But Cascadia as a whole is a manufacturer with a story behind why we're a manufacturer, because we didn't choose manufacturing by choice. We chose it out of necessity. Our company was started by a group of building science engineers about 10 years ago. And at that time, just before the company began, these building science engineers had been operating in Vancouver, British Columbia, and in the Pacific Northwest of North America, helping the industry in that region for about the last 15 years up until that date overcome what had become known as Vancouver's leaky condo era, a period of time where the design and construction of the exterior of buildings and building envelopes had been found to have many premature moisture-related failures. And this was a terrible time for that local industry, although it is now referred to in the past tense. It has happily been overcome. These engineers were looking forward and saying, well, since this problem has been virtually solved and overcome, what are we going to do with our employee base that has grown from 6 to over 100? What's the next problem that we can solve in the industry? And around about 2008, it became evident to them that was going to become an attention on energy conservation in buildings. So they were kind of thinking of it big picture. How could they leverage their experience and knowledge with building envelopes to assist with helping buildings become more energy conserving? And they figured that, well, for a building envelope, by far the weakest link is the heat loss or the heat gain, and that is through window assemblies. So they looked around and said, well, how can we improve window assemblies? And they found that aluminum was a very highly conductive material, and it couldn't help that very much. And vinyl had some structural limitations, and fiberglass became a material that had the structural characteristics necessary for large and commercial windows, and the thermal performance characteristics necessary to help them achieve their goal of energy conservation, but nobody was manufacturing it. So that's where we circle around to Cascadia was born out of a necessity by these building science engineers to want to be able to use the products which we now produce. They had to start this engineering company to create the windows they wanted to use.
So Cascadia has been basically in business for about 10 years now. Is that what you said?
Yes, that's correct. We've been able to grow every year and take on some new partners in addition to the original founders.
So today, 10 years later, how are things going as far as markets that you're serving and whatnot?
Well, 10 years ago, the year that we started in actually was 2008. And if you remember the construction industry in 2008, turning 2009, what an amazing, roaring economic time to start a construction company. Well,
yeah,
not really.
That's probably about the worst time you could have started.
It turned out to be the very, very worst time, and it was a painful start, especially as we reinvested any money we made back into our products, back into our processes. But now we have grown about 29 or 30% every year, compounded annually, and we are now serving markets that stretch from Alaska down to San Diego, California, and everywhere on the West Coast in between. We've also been much more recently expanding our attention and our offerings to the New York area and the greater Eastern Seaboard area and other areas on the East Coast, as well as eastward across Canada, including Alberta and into the prairie provinces.
So is your product, would you consider it to be commercial or residential, and what kind of buildings does it typically go into?
Yeah, that's a good question. The intent of our product is to be what we refer to as commercial grade. And when I use a term like that, I'm speaking to the product's strength, its physical strength, its longevity of its service life, and also its physical test ratings. That all would be well summarized as commercial grade, but it's used in both commercial construction and in residential construction. The major types of projects that we see over and over again are kind of fall into three categories. Number one, high-end custom homes for owners who want to build something that's very durable and energy conserving. Number two, rehabilitation and retrofit projects, buildings that have had, let's say, moisture damage through the building envelope, have pushed the building owners to want to repair or update their building, and they want to do this retrofit with something that has greater durability and greater water tightness. And then the third type of buildings is commercial and institutional buildings where long-term value is really key for the group that's building it, like schools and hospitals.
When an owner is making a decision to use your product, what other types of products are they typically considering?
Well, for our fiberglass product, that question is actually different for us than most other fiberglass window manufacturers. For us, the other products that the owner is typically considering is aluminum windows. And mostly that's because there is either building code limits or just a general reluctance for widespread use of combustible windows and composite windows in non-combustible and commercial construction. Typically, combustible or composite windows haven't been used in large-scale commercial construction just because of a perception that they're not strong enough. So we are generally used where you want a strong commercial-grade window, but you also want a window that's incredibly thermally efficient. And up until our product line started to come into its own, those have been almost exclusively separate kind of design criteria. You could either get commercial grade or thermally efficient, but not both together.
I use the word combustible. Could you explain that a little more, please? What the context was there?
Yeah. So generally speaking, when you're dealing with a large-scale commercial building, you are, of course, dealing with a concrete or a steel building, which is a building required to be built of non-combustible construction. And as you probably know, most windows are combustible. PVC windows, fiberglass windows, and wood windows are combustible. And thermally broken aluminum windows are combustible as well, but because of the prevalence of the aluminum on the outside, they are perceived, rightly or wrongly, to be windows that are more suitable for non-combustible construction. But from a scientific point of view, there really aren't meaningful differences. So as wider spread use of combustible windows and all types of windows are used in commercial construction, North America will tend to catch up with the rest of the world in that respect of using composite windows where there's the biggest advantage for that.
So why would an owner select a fiberglass window over a aluminum window?
So an owner is going to get the necessary strength out of either a choice of an aluminum window or certain fiberglass windows. And in that context, I'll include our product in certain fiberglass windows that are strong enough. But the differences that they would be choosing between, for a fiberglass window, you're looking at somewhere between a 50 to 100% improvement in the thermal efficiency of the fiberglass product over the aluminum product, and the price will be very, very close to the same. In some cases, the fiberglass window will be marginally more. In other cases, it might even be marginally less.
Do you find that price is ultimately the deciding factor, or do you see customers looking at the positive attributes or the pluses and minuses when they're making decisions?
Yeah, you're right that the decision is usually more complicated for purchasing a fiberglass window than simply is it the lowest price. And definitely for our product, they are not the cheapest product allowed by law to fill a hole in a wall. They are definitely not that. Although they are priced competitively to many other choices that don't perform as well as them. So to circle back and truly answer your question, sometimes the decision simply comes down to price, but typically, especially for projects where the designer has sought us out on behalf of his or her client, the decision is based around the pluses and minuses of performance and longevity and environmental profile, not simply the lowest cost.
So there's a standard we call it in the window industry, we call it NAFS, but the North American Fenestration Standard, and it's a code required window test standard for North America. Can you describe what that standard is and how Cascadia assures its customers that their window will comply with the standards?
Yeah, absolutely. The last part of that is easier, so I'll address the first part of it mainly. So the North American Fenestration Standard, or we often say NAF, is a standard that collects together a group of physical tests that are intended that a manufacturer would subject their window to this group of tests to show that all aspects of its physical performance are adequate and are tested and have gained a rating that can then be used to compare whether or not the window is suitable for a particular building, a particular exposure, a particular wind speed. So that group of tests that this standard requires includes a strength test, so we say structural strength, and a water penetration resistance test, and an air leakage resistance test. Additional tests, which are usually referred to as kind of secondary tests compared to those, also include testing for resistance to burglary and the operational force necessary to work the Windows hardware. That cannot be too difficult or too tight. And then depending on the type of window, there are further tests to ensure durability. Certain products require cycling. And the result of this testing, this battery of tests that a single window or door would be subjected to, results in a window or door getting what is called a performance grade, which is a summary value that is described in this standard. And the performance grade indicates that, of course, all the tests have been completed and passed. And second, the performance grade is actually a number that refers to the design wind pressure for a building. So that number, if it is a low number, would indicate that the design wind pressure that window could withstand and succeed in all those tests is a lower number, which would equate to making that window or door suitable for use on maybe a single family home or a low-rise building that has lower wind loads. And then if it has a very high number as a result of this testing, then it would indicate that it's a stronger window, it's a more watertight window, and it is more suitable for applications on buildings with greater exposure, taller buildings, buildings in areas of particularly high wind speed, things like this. So finally, the last part of what you asked me, how does Cascadia make sure that we're complying with this and offering our customers well-tested windows? We engage with Intertech testing and other independent test labs to make sure that our products are fully tested. And we've developed a library of different tests that have been done over time to ensure that when our customers order custom products from us, and for us, that's all products, they're all made to order. that whatever configuration, size, and shape of products they choose has been covered in one or more of our past tests. Now, in addition to doing the physical tests, Cascadia takes one step further, and this has nothing to do with code compliance. This is because we think it's a very good idea and want to build up a sleep at night factor for our owners and our shareholders. And that is that we conduct in-house testing on a regular basis, virtually a daily basis, which is water penetration resistance testing in the same way that the laboratories conduct water penetration resistance testing. And we do that with a large wall which sprays water and provides air pressure on window samples. And the products that we conduct this regular testing on in-house are actually our customers' products. We've developed a practice of how to use our in-house testing equipment to non-destructively test the products that are coming off of the assembly line. So rather than just testing one particular specimen that, for example, the best technician put together and inspected, instead of testing just one specimen, on our daily testing, we're testing our actual customers' products, up to 10% of them that are coming off of our production line, and they'll end up getting water tested before they go out to our customers.
That's really good. So what happens if one of them leaks? What do you guys do at that point?
Yeah, that's super rare, but it would be irrational for me to say that they never leak. So when a product leaks or otherwise exhibits some sort of result that's not a perfect pass of our own testing, it's a really wonderful diagnostic and training tool. As I'm sure you can appreciate, a window is constructed of more components than simply 4 pieces of frame and a piece of glass. There's a lot of accessories, there's a lot of joinery, there's a lot of hardware involved. So we're able to take the production staff members and the supervisors that are related to the area in our production that assembled the component that resulted in the leak, and that's very easy to diagnose. It's very easy to observe a leak and know what caused it. And then we can bring them over to it and say, hey, look, this is the result we've just got testing this morning. Here, take this window, take it apart a little bit, diagnose it, and then give it back to the testing worker, get them to retest it, and check your other work you've done in this batch. And so in that way, we're allowed to combine training and quality control in kind of the same practice.
Good stuff. I want to go back to NAFs for just a second, just for the benefit of listeners that may not be familiar with it. So North American Fenestration Standard. North America means Canada and the US, correct?
Yeah.
Yeah, so that's something that, just for those that are listening, it hasn't always been like that. So, and I can't remember if it was 10, 15 years ago when they first started producing the Canadians window organization and the Americans combined. So I think that made things a lot easier to cross borders, obviously, by using the same standard. The other advantage of NAFs, and you described the ratings that they have and the numbers and whatnot, is that, you know, everybody's basically using the same standard for testing, and it gives an opportunity to compare products, making sure basically they're apples to apples when you're comparing two products. If you had one of your products that had a higher rating than a competitor's, you could differentiate that by the ratings. Did I explain that well? I'm not sure if I did.
That is good. And actually, Paul, I'd like to leave your listeners with just one more comment, kind of a little pearl of wisdom related to selecting windows and understanding how a manufacturer makes a choice for a trade-off when they're conducting NAFs testing on their products. And that is that because the NAFs testing includes a structural test, which is performed by applying air pressure, basically wind, to the outside of the window in both the inward and the outward direction. Because every window has its own physical limits, the strength of the frame, the strength of the glass, and the strength of the hardware that keeps it shut, regardless of what the weak point is, there will be a weak point, and it means the trade-off that must be decided upon by the manufacturer is the size of the product to be tested. that if you have a larger product, therefore, when you add up the amount of pounds per square foot of air pressure, you have a higher amount of pressure overall because you have a bigger product. And why the size of the product is so critically important is because the NAF standard allows a manufacturer to build a product that is the same size or smaller than the NAF test, but not bigger. You can test, you can build what you test, or you can build more conservatively, but you cannot extrapolate results, and both height and width are independently restricted. So if a manufacturer has a product that they want to claim a very high test rating on, then it makes sense for that manufacturer to choose the smallest allowable sample with which to perform the test. However, if the manufacturer wants to be able to legally and properly sell and have a tested product that is a large product that will enable them to sell to many customers who might want a larger window, whether it's an opening window or a picture window or whatever, logically, a larger test sample is a more versatile test. It will cover more future orders for different sizes of that same product type. But the larger test will result in a lower pressure. So the nugget of wisdom that the potential buyer or the specifier needs to recall is that for your particular project, for your particular home or school or whatever building you're working on, the fact that a manufacturer has a high pressure, a high rating in a test, doesn't necessarily mean that they can produce your windows at that test pressure. They may have done a test for a very small window to create a very good result, but in fact, they may either not have testing on larger windows, or they might have testing on larger windows, which has a much, much lower rating. So you simply ask, don't be super suspicious or negative to your potential supplier, but definitely ask. And if they don't have a test, or if they don't have a test at the necessary rating to build that larger window to the pressures that your particular project requires, then that's just because physics got in the way, and that product line may not be the product line suitable for your project.
So if somebody asks the question about size, what would a manufacturer do to evidence what they did test at?
Yeah, that manufacturer, ideally speaking, should send that inquiry, that customer or that professional, a test report from an independent test lab. And right on the front cover of that test report, there will be the performance grade, which I mentioned before is a summary value indicating that all the testing was done and the wind pressure at which the product survived was a certain number of pounds per square feet. So you'll have performance grade with that number illustrated as a performance grade 30 or PG 30, for example, indicating that the product can survive up to 30 pounds per square foot of wind pressure. And then right after that number, there will be a size test with dimensions. And those dimensions are limits. It means that test is relevant for that type of product built up to that size and not bigger.
So if the dimensions, just to make up numbers, were, and we'll use inches here, 48 inches by 48 inches, which is 16 square feet. If a manufacturer then wanted to sell a window that's, say, 36 inches by 60 inches, which is actually lower in square footage, 15 square feet. What I heard you just say, they could not do that because the height exceeded the tested height, the 60 inches.
Yes, it's correct. Even though your mathematics, looking at the overall square footage and therefore the overall area the pressure is applied to, it's less square footage, those dimensions are independently restrictive and cannot combine them for square footage in order to interpolate. The logic behind doing this is that, let's say that you take an operable window, whether that's a sliding window or a casement window, and you picture the hardware and the locking points that are necessary to keep that window shut in a storm. That hardware component, in your example, it would be a 48-inch component in the first dimension that you gave. In the next scenario, you set a 60-inch dimension, and that may be the same component that's used on the same window product, but now it's having to create locking over a 60-inch dimension, not just a 48-inch dimension. As a result of that, the physics are different, the forces are different, and whether or not that window is capable of being built that size is not the point. The point is that the test does not permit you to exceed the dimensions.
Because you don't know how it would do until you test it.
Correct. That's the logic of the standard. Now, a lot of companies will say that they can get engineering to do that interpolation or extrapolation, but that's not entirely correct. Engineering has a limited role to play in compliance with the NAS test standard, and usually engineering is limited to the design of the frame components that would be in the center of an overall window perimeter frame. Let's say, for example, that you have a casement and a fixed window, and you will mull them together or couple them together in the field when you install them. That connection, that frame component that therefore goes through the middle of your window opening, that can be engineered utilizing generally accepted engineering practices. And that's something that the test standard allows, as long as those components have also been subject to all the rest of the testing. But in terms of interpolating or extrapolating size, no, quite explicit about that.
Yeah, and I'm glad to hear that, because it wasn't always like that. I can, the word I remember is comparative analysis, and they would use the area dimensions to qualify different products, which really gave an awful lot of latitude. And as you just, skillfully explained, it doesn't always work.
Yes, you're absolutely correct. Yeah, in fact, it's an aspect of the industry that is at such a detailed level that the enforcement of the standard and the respect of that particular aspect of the standard, those limits, that's something that has not always been evenly and fully enforced or even understood, both on the building design professional level and the building official level, the authorities. But as everybody becomes more educated and more practiced by using and applying the current version of the standard, hopefully the industry all comes up together. From a manufacturer standpoint who invests a lot of money and a lot of research, time, and attention into making sure our products are fully in compliance, we have in the past been irritated to see other companies, you might almost describe it as get away with supplying products which are not as fully tested as the products that we would propose and compete with them on.
Yeah, well, there's always the that element of the market looking for the cheapest price they can find, and that's probably what that caters to.
Yes, it's true.
So I know Cascadia obviously is not the only fiberglass window manufacturer. How are Cascadia fiberglass windows different from other fiberglass windows?
Yeah, that's a good question. But first, I'll touch on the similarities. Fiberglass was created as a window frame material over 30 years ago in order to solve compromises. And it's actually probably the newest of the mainstream window frame materials. Let's say that the other three are wood, and aluminum, and PVC. And wood, aluminum, and PVC had some historical compromises: durability and maintenance for wood, thermal performance and condensation problems for aluminum, strength and dimensional stability and restrictions on large sizes for PVC. So fiberglass was introduced as a window frame material to combine strength similar to aluminum and thermal performance as good or better than PVC in a window frame material that basically solves compromises. So in that way, our fiberglass windows are similar to pretty much all fiberglass windows, having the basic characteristics that they cannot rot because they're not organic. They cannot rust because they're not metal, and they have a very, very low coefficient of thermal expansion and contraction, which means they won't cause their own components to experience fatigue over time, the same way that plastic window would. However, that's where the differences between our windows and other fiberglass windows kind of ends. Other fiberglass windows have been designed to be suited to residential applications, and the sizes and the environmental and physical loads that are all typical of residential applications. When I say that, I mean houses and multifamily buildings that are low-rise. But our windows, even though they're used in some of those types of projects, have always been designed to be commercial grade. And when I say that, I mean that the collected characteristics of being a higher strength from an engineering and testing point of view, having higher test ratings, which means they're more appropriate for exposure in high wind and storm areas and on tall buildings, and their lifespan and the longevity of all the components, down to even the material with which the hardware is made out of, and generally being stainless steel. All of these components combined together are designed to be commercial grade for strength and longevity and exposure.
So commercial grade windows obviously have higher performance criteria structurally and rainwater penetration and whatnot. So how did Cascadia design their windows to meet these higher ratings?
Yeah, that's a complicated question. How do we design a window to meet higher ratings and to deserve the term commercial grade? And I should point out that terminology that I'm using when I'm saying commercial grade, that's not a defined term in the industry. That's just a summary term that I'm using to apply to those criteria of strength and longevity. But how do we design for that? Well, we start by having our technical team come mostly from our founders and also from some fenestration specialists that have worked in windows all their life. The technical team, in summary, has a strong building science background, and part of that is from pretty much growing up our skills and experience in a situation where our city and our region in North America was experiencing a leaky building crisis for years and years and years. So we understand both the importance and the detailed level physics behind making buildings and the products in buildings very, very watertight and having multiple lines of defense against water. So from having a team that has that background in making buildings in general have great water penetration resistance, and that experience including the interfaces between different products, different membranes, different seals within a building itself, when you have that experience and you understand the physics behind it, you can then actually apply that at the product level as opposed to the assembly level. And in that way, we've been able to make sure that we've applied our first principles thinking to the water penetration resistance of our product. Essentially, that means having multiple seals. It means having meaningful drainage and pressure equalization existing between the seals within a window that opens and closes. And after all of those engineering principles have been applied and they result in a product that's been built and has a test, we further ensure that our windows are designed to meet these ratings by testing in-house every day. We're testing between 5 to 10% of all the windows we actually produced, and we continuously prove for ourselves that the testing success that we got in a laboratory once every few years is not just a one-off success that the best technician in the factory was able to achieve, but in complete contrast to that, the results are proven every day in the normal course of production across multiple shifts. And so from both an engineering standpoint and an in-house regular testing standpoint, we assure our customers of those high water penetration resistance ratings and that aspect of our NAST compliance in particular.
So that addresses a big issue I have with window testing and certification, in that it's not always repeatable in the field. I know that sometimes, you can get the perfect test in the lab and get your rating and then go start building windows and installing them. And lo and behold, it doesn't seem to pan out the same way in the field. So I think it's really good to hear what you guys are doing. And I wish more would do. I know other manufacturers do test products off the line and whatnot, but it's a problem that we see with water leakage, and that products don't always perform up to snuff with what their rate, how they were certified and what they're rated for.
It's true, actually. It's interesting to hear you comment about the differences between a company's lab testing and the testing that you experienced during your professional practice in the field. And I actually come from the building science consulting field myself before I joined Cascadia as a manufacturer. And I, too, was involved in actually performing water penetration resistance tests on construction sites that involve both walls and windows. So I understand that it's very, very different to see an installed window that's a production line product being tested in the field compared to what the laboratory says you should experience. One of the things that has influenced our decision to do this optional, so not code required, in-house testing that I was describing earlier, is that in our home market, which is Vancouver and the Pacific Northwest of North America, the leaky condo crisis that I referred to earlier, where there were many premature building failures or building envelope failures due to moisture ingress, caused a hypersensitivity in the industry to water ingress, rightfully so. And the result of that hypersensitivity has been the ongoing normal practice of rigorous water penetration resistance testing on construction sites. And pretty much any construction site of a commercial building that's greater than let's say larger than a bank or a restaurant, and most multifamily residential buildings that are, 4 stories and higher, water penetration resistance testing could be conducted on any project, but it is routine to have it on every project that's bigger in scope than what I just described. And that's not the practice in all regions of North America.
So, Michael, what kind of warranties are available with the Cascadia windows?
Right. So Cascadia's windows and doors are warranted for all of their fiberglass frame components for 20 years, and their hardware and glass components for 10 years. And the interesting thing about our warranty compared to some other warranties is that ours is a product warranty, and it's not fraught with a bunch of exclusions that are designed to kind of negate the warranty and our obligations under it. If you look at some warranties, and this is just a caution to potential buyers, not a slight against any other manufacturer, some warranties are limited where if a residential owner sells their house, the warranty concludes with their ownership. It doesn't pass on to the buyer. Differently as well, some warranties are different for commercial applications and installations where there are hundreds of windows compared to a single-family homeowner. Our warranty is the same for all products in all applications, and it doesn't matter if you sell your house, change ownership, change the use of the building. The product is the product, and therefore it carries the warranty.
We were talking a little bit before we started the podcast about Hurricane Irma, and we've learned some warranty lessons since then. We had a project in Florida that had some issues with the roof, and we asked the manufacturer, the roof had some uplift issues. We asked the manufacturer to come out and take a look at it, and they refused to come. We asked them why the refusal, and they produced their warranty that said that the warranty is void for any winds that are higher than 55 miles an hour, which is really, really sleazy, I think, since they're selling roofs in hurricane-prone areas where the design pressures are way, way higher. The lesson learned is read the warranty, folks. Read it, because just because you get something that says warranty doesn't mean you're getting much.
Yeah, and some warranty documents, they can look thorough, they can have a long time attached to them, but they also have a lot of exclusions that exempt the manufacturer from their obligations. So I think the best warranty is the one that doesn't have such exemptions. The time period is less important than the strength of the warranty during the time it lasts. Very true,
as we're seeing. So speaking of Hurricane Irma, has that had any effect on Cascadia's business?
Geographically, we're not we're not commonly serving the market that's affected by Hurricane Irma, but although we are willing to, and our expansion efforts would definitely include that area now and in the future. But the effect that we're seeing is just all over the whole North American industry. There's definitely a noticeable increase in the amount of attention to resiliency. And in some ways, it's almost becoming a buzzword. But, as much as I hate buzzwords, I think the attention to it and the awareness of it is good for the industry, good for the buildings that result from this. So increased resiliency when it comes to product selection is something where our potential customers are now giving more attention to our test ratings, the types of materials that we're using in the construction of our products. So I think it's having a good result on buying decisions, and it's increasing the number of items that people consider when they're trying to assess the value of a product, not simply its price. One more thing that I'd like to add about Hurricane Irma, related to our earlier discussion about the physical tests for NAFs, is that although the products themselves are subjected to NAF testing, the way that the products are attached to a building, the installation attachment, is not part of the NAF standard. And the products that are being tested can be attached for the purpose of testing in any way that the manufacturer wants. That you can overkill the method of attaching the product, and that's not something that's tested or rated in the standards. So the takeaway from that is that a builder or an installer should be careful to meet or even exceed the recommended attachment that the manufacturer makes, or that the building engineer prescribes. In particular, being careful to not do less. And if there is no information from a certain manufacturer, then information should be sought. You shouldn't just do what you've always done, because the environmental loads and the wind pressures on one building could be different than another.
Yeah. So, Michael, if listeners want to get more information about Cascadia windows and doors, how would they go about doing that?
Yeah, the best way is to start with our website, where you can discover both a summary of our tested products, a gallery of examples of our product's use, and a description of even our newest product, which is a brand new fiberglass commercial grade passive house certified window and door line. And this line is our newest technology. It's called the Universal Series. It's gaining a lot of ground because it's not only our highest performing product, it's also our least equal or least expensive product that we've ever made. So all that information is found on our website, and our website is cascadiawindows.com. And from that point, I would invite anybody who's interested in discovering more, or if we can just be helpful by sharing some technical information, just to reach out to us with whatever method is convenient, whether that's email or telephone. It's easy to find our contact information on cascadiawindows.com.
So, Michael, it's been very interesting and informative. I really thank you very much. And I know the listeners, I'm sure, enjoyed the material today. So thank you very much for coming on the podcast today.
Oh, you're welcome, Paul. It's been a pleasure.
So thank you, everyone, for listening to the Everything Building Envelope podcast. Please tell your friends and colleagues about it. If you'd like to subscribe, it can be found on iTunes and Android outlets such as Stitcher. And until next time, this is Paul Beer saying so long.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.